Okay, I think we can go ahead and get going. I think we have a good critical mass of individuals. Thank you for joining this technical showcase event. Very excited to have you here and share a little sample of some of the awesome work that we're doing within these logistics teams here at DoorDash. We have an awesome lineup for you today, so I think we can kick it off. Ezra, if you don't mind, jump into the next slide. So starting with a quick introduction about what we'll be talking about today, as well as sort of like an overview of what this logistics team is responsible for here at DoorDash. And then from there, we'll jump right into our keynote presentation from Alex about how DoorDash powers our dispatch engine with ML and optimization. Should be a very interesting talk. And then we'll jump to the lightning talks after that. So building Dasher dark mode from Laura and Pradeep, managing supply and demand balance from Stas, increasing assignment experiments by 1,000% from Sifeng. Yes, that's right, 1,000%. That's not a typo. Really fast experimentation that we do here. And then last but not least, optimizing merchant order capacity with real-time pipelines from Aditya. After that, we'll do a little panel. So we'll get to talk to some other folks from the team and ask them questions about their experiences here at DoorDash, other projects that they're working on. And we'll wrap up with some Q&A opportunities for you all to ask us questions. One note is that you should actually also feel free to drop questions in the chat, the Zoom chat that is, throughout the presentations, and we'll do our best to keep up with those and answer them as we go. In addition to that, you can keep an eye on the chat. We'll try to post announcements and relevant links as we go as well. So if there's any extra materials, the chat will be the place that has them. And then Ezra, with that, we can jump to the next slide. Thank you. So first of all, we can start with this overview of logistics, what we're responsible for. So what is logistics at DoorDash? This is the set of teams that's responsible for the fulfillment of deliveries. So everything from when an order is placed to when it finally shows up at your door, all of the decisions that we need to make or actions that we need to take to try to ensure that that delivery goes smoothly. So a few components of that that are pictured on this slide. This isn't necessarily comprehensive. There's a lot that happens to make these deliveries go smoothly, but trying to highlight some of the areas that you'll hear more about in the lightning talks and other discussions. So first of all, on the left-hand side, how we build a fantastic product for Dashers. So all the way from the first time a Dasher hears about DoorDash to their onboarding onto the platform, background checks, passing sensitive information like social security number, that type of thing to register with DoorDash, and then how they actually can go do a bunch of deliveries, how they can earn a wage, pay their rent, do all these types of things via the programs that we offer. That's kind of this core Dasher experience and the set of products there. In the middle, what this picture is sort of showing is how these teams make optimal decisions so that every delivery goes smoothly. So how we match Dashers and deliveries in real time, how we balance supply with demand, all this sort of intelligence that needs to happen behind the scenes to guide these Dashers appropriately to fulfill these deliveries as effectively as possible. And last but not least, on the very right-hand side of this slide, how we actually go about streamlining merchant operations. Every single one of these deliveries is done for a customer, but it is also done on behalf of a merchant, a third party who controls the inventory that DoorDash is simply integrated with. So how do we actually streamline that integration, make it as effective as possible for the merchants, as well as the customers receiving the orders, as well as the Dashers actually fulfilling the deliveries so that all sides of the marketplace benefit? So again, super high level, what logistics is responsible for. With that, I think we can jump right into some of the discussions from the awesome folks that we have on the call. So we'll hand it over to Alex to speak to this first area of powering dispatch with ML and optimization.
Awesome. Thanks a lot, Rohan, and welcome everyone. I'm super excited to see the great turnout here, and especially to get to talk to you about a topic near and dear to my heart, which is how we power dispatch at DoorDash with machine learning and optimization. Ezra, if you go to the next slide, I'm going to give a quick introduction. My background is in operations research. I've been at DoorDash for just over a year. I hit my 1-year Dashiversary last week, so that was an exciting milestone. But I've spent the last 4 or 5 years working in the tech industry on logistics problems at Lyft, Zillow, and Amazon, and really excited to be at DoorDash and tell you about sort of what drew me to DoorDash, which is this dispatch problem. At DoorDash, the data science and machine learning team, which I'm on, embeds on our product verticals. So you'll see, I'm going to talk more later on about collaboration, but you'll see how we collaborate across data science, engineering, and product. And here's the agenda for today. So I'm going to tell you about sort of understanding what is the dispatch problem to begin with, how we built our dispatch engine using machine learning and optimization. And then I want to spend some time talking about how we make dispatch 1% better every day, which is a really important idea at DoorDash. So in order to understand what the dispatch problem is, you need to understand our marketplace a little bit. So there's kind of three participants in our marketplace. There's merchants, consumers, and dashers, and they're each looking for something when they come to our marketplace. So our merchants are trying to reach as many customers as possible, and in doing so, maximize revenue through sales. Our dashers want flexible working arrangements, and they want to earn as much money as they can. And our consumers want the convenience of ordering from home, and they want selection. They want to be able to find their favorite merchants and discover new ones. So with that in mind, it kind of brings us to understanding the delivery life cycle. So, and how each of these marketplace participants interact. So it starts with a customer placing an order, and DoorDash receives the order, and we do two things. We send the order to a merchant to start preparing the order, and we send the order to a dasher who will go pick up the order. The dasher will pick up the order at the merchant, and then they'll bring it to the customer, and hopefully the cycle starts again with the customer ordering again if they had a great experience at DoorDash. So the dispatch problem is really focused on 2B in this diagram. And when I talk about the dispatch problem, I'm talking about how we decide which offer to send to which dasher in order to do two things. One is maximize dasher efficiency and help them earn as much money as possible. And then secondly, we want to deliver orders fast and on time so that our consumers and our merchants have the best possible experience. So now that we understand what the dispatch problem is, I want to take you on the journey through our dispatch engine. And it starts with a new order coming in. And the first thing we do is we construct route candidates. So we consider all those new orders. We consider what dashers are out and about available to pick up orders. We also consider, are there any existing orders we know about that haven't been filled yet? And it goes to this stage of constructing route candidates. So on the next slide, you'll see what I mean by this, which is that we're sort of considering this network. We have a bunch of dashers who are somewhere in the world, and they might be near some merchants where we need orders. Hopefully they're close to a merchant that has an order. And we're going to consider all the possible pairings of dashers and one or more orders that could be picked up. And then once we've constructed these route candidates, we send those route candidates through to our machine learning layer. The purpose of this is to try to understand essentially what's going to happen if we choose that route candidate. There's three models that go into this machine learning layer. So the first is our order ready time model. And this is kind of one of the most important aspects of understanding what will happen with the route. If we don't know when the order is ready, we can't really decide when to dispatch the dasher. The other piece is travel times. We need to know how long it'll take the dasher to get from where they are to the store, and then from the store to the customer. And then finally, what's the likelihood the dasher will actually accept the order if we send it to them, which is another key consideration when making these dispatches. We show an example here of one of the challenges that we deal with when trying to train our machine learning models. So this is for order ready time or prep times. When you're training a machine learning model, you really want to be able to identify a label which says, like, for this set of historical orders, what was the actual prep time? The problem is it's actually pretty hard to observe directly what the actual prep time is. If the dasher was early, then they waited a little bit, and we have a pretty good sense that when the food was when they actually picked up the food, tells us how long it took to prepare the food. The problem is with the other case where the dasher arrives after the food's ready. If they're not waiting at all, we don't really know if the food happened to come out exactly when they got there, or has it been sitting on the counter waiting for a while. A lot of time merchants are so busy, they don't really have time to tell us that the food's ready. They know a dasher's on the way. So we have to try to interpolate that signal of when the food was actually ready. And we have a great post on our blog that goes into a lot more detail on how we make that interpolation, which is a good opportunity for a quick plug for our engineering blog. There's a lot of amazing content on there, especially about our machine learning work, but also about our engineering work in general. So highly recommend checking that out if you haven't. But coming back to, so we've estimated all of these quantities, and now we get to what I consider the most exciting part of the process, which is optimization. And our optimization model, so it's the most exciting part of the process, but it's probably the most boring slide. I show you here how we solve our optimization using mixed integer programming. This is kind of a simplified version of the model that we use in production, but essentially mixed integer programming allows us to decide across these different route candidates which ones to assign by trading off between efficiency and quality. So when I talk about efficiency, I'm really talking about dasher wait. If the dasher's waiting a long time at the store, that means we probably didn't make an efficient assignment. We could have assigned a dasher later on and they wouldn't have had to wait as long. On the flip side, when I'm talking about quality, I'm talking about the food waiting, basically. If the dasher's not there when the food's ready, then the food's sitting on the counter. It might start getting cold, or it just isn't getting to the customer as fast as it could. So those are the two things we're trying to balance. And hopefully we get the dasher there as close to the perfect time as we can each time. But in order to do that, the key decisions we have to make is which dasher is the right dasher to pick up this order, which orders can be batched together. Maybe there's two orders at, I don't know, Chipotle, and they're both going to customers who live pretty close by. Maybe a single dasher can pick up both of those orders. And then the final question is, do we dispatch now or dispatch later? So if we go back, go to the next slide and look at our output of our optimization model, there's two things that can happen. One is we decide to make a dispatch. We decide to offer that order to a particular dasher, or we could decide to delay dispatch. Maybe based on our food prep time estimate, it's not really time to dispatch a dasher yet, and we can hold off, send it back as an existing order for essentially the next cycle of dispatch and reconsider it later on. So that kind of, you've walked through the entire process of dispatch at DoorDash. And I want to wrap up by telling you how we make dispatch 100% better. 100% better would be great. 1% better every day. The 1% better every day is one of our operating principles, as I mentioned. And I love that idea because it's all about incremental progress, and the idea that when you get 1% better every day, that improvement compounds throughout the year and leads to sort of astronomical gains over the course of the year. When we think about it in terms of dispatch, we're constantly iterating on our machine learning models and our optimization models to try to do a better job striking that balance between efficiency and quality. And in particular, we leverage two platforms to make these improvements. One is a platform that's relatively new that we're still iterating a lot actively on, which is our simulation platform. And this allows us to test things in an offline setting before sending them to production. And we could get some signal about, is this going to be an effective change that doesn't hurt anything in our marketplace before we take the risk of putting it out there in production. And then at the end of the spectrum is experimentation. And this is a platform we rely extremely heavily on. Sifeng is going to tell you a lot more about this later on in his lightning talk about how we've improved our experimentation platform 1,000-fold. But we run dozens of experiments every week on the dispatch team alone. And it gives us an amazing insight into how these product changes are going to affect the marketplace. Another operating principle we have is one team, one fight, which I have in my Zoom background here. And I think dispatch really embodies this principle as well. Everything that I presented today is a huge collaborative effort with team members from engineering, data science, analytics, machine learning. We have folks with specialized background in operations research, and we're always working with our product manager to drive the right changes for our product. On top of that, we collaborate with a lot of other teams, including our platform teams, our machine learning platform team, our experimentation platform team, infrastructure that supports what we do day in and day out. So there's no one person that makes this possible. It's for me, this is, in addition to the great problems I get to work on, this is the best part about working at DoorDash, is the great teammates that I have. And with that, I'll just leave you with a taste of what's ahead for Dispatch. We're really growing as a company in at least two major directions. One is geographically. We've expanded a lot internationally with recent launches in Australia, Japan, Germany. Who knows what'll be next? But this opens up exciting challenges for Dispatch, where we have to now think about how to operate and how to dispatch in different geographic settings. There's different layouts geographically, and there's also cities that'll have a totally different mix of vehicles. Maybe most dashers are delivering by foot or by bike. This raises all kinds of challenges for our travel time estimates and how we make those trade-offs. So that's one area. The other area we're expanding is into new verticals like convenience and grocery, alcohol, and I'll call out our Double Dash product, which basically allows you to have a single dasher pick up orders at multiple stores for you before coming to you. And again, this makes for really interesting problems for Dispatch, where we have to think about what's the right dasher to pick up at both these stores. Are these stores good candidates to be picked up by the same dasher? All kinds of interesting stuff there. And just as we grow as a company, we get more density, we get more orders, and we get more data. And for me as a data scientist, that makes my job really exciting. And I'll leave you with that and hand off to our next speakers, Laura and Pradeep, who will tell you about the amazing work that we've done to build dark mode in the Dasher app. Thanks, everyone.
Thank you, Alex. My name is Laura, and I'm here with Pradeep to talk about how we enable dark mode in the Dasher app. A little bit about myself. I'm an iOS engineer in the Dasher team. I've been at DoorDash for over 3 years now in the logistics organization. I primarily work on navigation and drop-offs, just making sure that Dashers are taken to the right spot and they can drop off the food as fast as possible. And I'm an avid hackathoner. I've actually participated in multiple hackathons, both inside the company as well as outside events. And I'll be talking a little bit about that in just a second. Pradeep, do you want to introduce yourself?
Sure. Hi, everyone. I'm Pradeep. I'm an Android engineer. I've been part of DoorDash for close to 3 years now. I'm on the same team as Laura, but more focused on the platform side, wherein we are working on building the next generation fulfillment platform. Yeah.
Sounds good. Thank you, Pradeep. So let me tell you the story of how we launched dark mode in our Dasher apps. It really all started with a hackathon. We heard from a lot of Dashers, especially Dashers that were doing deliveries late at night and for long hours. They were just having issues reading the screen, getting order information, details on pickup and drop-offs. It was just a blinding light, and it was simply not a good experience. There was also a lot of momentum for dark mode. Both iOS and Android support dark mode, and multiple apps came out with their own dark mode versions. And the image I have here is of a Dasher just driving at night and being blinded, as you can see by the white screen, unable to read anything. Next slide, please. Cool. So dark mode it looks great. It's amazing. As you can see, these lights look really good. But why is it really important? I think to me, there are three main reasons why dark mode is crucial to any mobile app. The first one is around readability, especially in low light environments. If you don't have dark mode, your users won't be able to read the content you show them. And this is also connected to the second point here, which is eye strain. Especially extended exposure to bright screens can cause dry, itchy eyes, blurred vision, and all kinds of potentially medical problems. And last but not least, dark mode provides better battery life. There have been some studies that show that especially in OLED screens. Dark mode can actually save up to 60% of a phone's battery life. So this is the Dasher app adapting to light conditions. As you can see, it's a light screen when it's bright outside and a dark screen when it's dark. And you can see that it's not just inverted black and white colors. It's a lot more involved than that in terms of grays and different tones to make sense for the ambience. And now Pradeep is going to talk more about what happened after the hackathon.
Thank you, Laura, for taking us through the hackathon journey. In the next few slides, let's take a look at how we ship this feature into production. The screenshots on the right are from the production applications with the dark mode feature on. And as you can see here, in order for us to reach here, we had to overcome some challenges on the design front and on the engineering front. And also, this required some close collaboration with the design experts. On the design front, some of the challenges were: one, we did not have a design theme that would translate to light mode and dark mode programmatically. Two, the existing design elements did not support dark mode. On the engineering front, all the existing screens were hard-coded and the branding was inconsistent. And two, developers, when adding new features, manually added more colors, which led to more code duplication and less efficiency. And lastly, how do we build a solution that's more scalable in feature to support multiple themes and multiple brands to one single application? In the next slide, let's take a look at how the design team came up with the design theme and what steps were taken on the engineering front to implement this new system. DLS stands for Design Language System. It helps us avoid using hard-coded colors in our application. And it also allows us to build a layer of abstraction on how the colors are being referenced. As you can see on the top, in the example, the screenshot is from the accept decline screen. And this is the screen that the dashers see when they receive an incoming order. The most prominent part of the screen is the dasher pay. And previously, this was using a hard-coded hexadecimal value. Now with the introduction of DLS theme, this was updated to a color semantic and it was named as text primary. And in our case, this text.primary, depending on the theme of your application, it would translate to different colors. On the engineering front, we had to basically audit all the screens to understand the look and feel of the application in light versus dark mode. The screenshot below is just a very small subset of all the screens that we have in our application today. The next step in the process was to basically build a theme on our applications that reflects the DLS theme given by our design team and basically reference this theme across all the different screens on our application. This is just high level. In the next slide, this is the end result of our feature. We basically tested this live on the streets to understand the before and after experience. And as you can see, the after experience in dark mode adapts well to lighting conditions, and it's also a lot better. For dashers, it made it much easier to interact with the application, look at the custom instructions, receive incoming orders. And most importantly, as Laura said, dashers don't have to worry about the brightness impairing the driving safety. And on the Dasher community side, we received really strong feedback and positive response. So next slide, please. Yeah, with that, thank you all for listening in. I'll hand it over to Stas to discuss about managing supply demand. Thank you.
Thanks, Laura and Pradeep. Hi, everyone. So my name is Stas, and I'm a data scientist that works on a team responsible for managing supply demand. This team is part of logistics, together with the assignments team that Alex talked about. Next slide, please. Yeah. So generally speaking, our objective on a team is to ensure that all orders get fulfilled. And if we have a lack of balance between dashers and orders, that usually means that dashers don't get enough work, meaning that they don't fulfill enough orders and their earnings get hurt, or consumers get the orders late if, for example, we have very high demand and very low supply of dashers. To achieve this objective, we focus on 3 areas. First area is identification, and this has to do with designing sensitive metrics on which we can actually action. And the second part of identification is actually trying to anticipate ahead of time where things might go wrong in terms of supply demand. The second core area on the team is to build levers that allow us to shape the demand or shape the supply. And these levers are generally categorized into two parts, which is proactive and reactive. And the last area that the team focuses on is generally improving the Dasher experience, so dashing becomes just a bit more rewarding. Yep. So on the metric side, good metrics oftentimes use as a trigger mechanism, an internal system, and they're used as an early indication that something might go wrong. So in other words, like we have a very high correlation with business metrics downstream, but they allow you to like react much sooner and action on it. So in the middle diagram, what I have is different orders that might be coming into our system. So some orders might be restaurant orders, some might be convenience, some might be retail, and we have a Dasher pool. So generally speaking, one metric we can think of is a ratio between orders and Dashers. So at the bottom on the left side, we have one restaurant order and one Dasher, one available Dasher. And in this particular case, you might consider the system to be like perfectly balanced because we have like one order and one Dasher. So we have a perfect supply demand. In the middle, you can see a case where we have 5 restaurant orders and one Dasher. And in this scenario, it would be very difficult for a Dasher to actually fulfill all 5 orders with constraint that consumers actually don't get their food late or consumers don't cancel the order because they're unsatisfied. However, context really matters. So knowing that the Dasher actually is fulfilling 5 retail orders, and maybe they have a bigger car, indicates that we have a good supply state because consumers might be less, more invariant about order lateness if it's not food-related order. Next slide, please. So, so once we identify like the metrics, the other part of identification has to do with like, where are we actually going to be undersupplied? And for this, we rely on forecasting mechanism. And we generally speaking have 2 types of forecasting. We do long-range forecasting, and this consists of time series models that have very stable statistical properties, like for example, exponential smoothing. And we also do short-range forecasting that consists mainly of GBM models that efficiently encode contextual information, and they're very scalable, meaning that we're actually able to predict up to the minute basis or half-hour basis at very small regions. For example, like what might be the merchant supply-demand imbalance. One important highlight is that both forecasting accuracy and uncertainty are very relevant. For example, when we allocate incentives for Dashers about where we're going to experience in order to incentivize them to move to a particular region, we use the uncertainty as a way of encoding just how far should we pull a particular lever. Next slide, please. Yeah. So after we identify through metrics and forecasts where we're going to be undersupplied, we need to take certain actions. We, largely speaking, break the actions down into 2 parts, which is proactive and reactive. So proactive is the levers that we adjust in anticipation of imbalance, and reactive are levers that we adjust in reaction to unanticipated events. So for example, someone asked a question about weather and how do we handle that? This would be actually part of a reactive lever. So if we anticipate, so if we observe in the near future some weather event, we might decide to adjust incentives or decide to allow more Dashers to come on the road and schedule their shift, or message Dashers. One highlight is that predictive models or ML models often fail in building good levers. So instead, we rely on causal inference techniques to debias observational data, or we rely on experiments in order to regularize predictive models. And on the right side, I have an example of that. So this actually shows the output of an ML model that encodes the relationship inside the model between incentives and expected Dasher hours or expected Dasher supply. And one thing that emerges from this is that as we increase incentives up to the $4 mark, we get more Dashers on the road, or we get like more engagement from Dashers. On the other hand, if we set very high incentives, the Dasher engagement drops. And this is actually oftentimes a case of like omitted variable bias or simultaneous causality bias that observational data has, and which ML models might mistakenly encode. So that's why we rely on experiments or causal techniques to debias these types of findings. Next slide. So lastly, our team recognizes that Dashers are a very important part of our success, and we work on a lot of initiatives to make the dashing experience just a bit easier. So one project we recently worked on is helping Dashers get orders on their commute to a particular region. In the two screens to the right, you can see a case where Dash is scheduling a region, and we essentially will try to assign orders before they even get to the region, which boosts like the efficiency. With that, I'm going to hand it over to Sifeng, who is going to talk about experimentation.
Hi, everyone. My name is Sifeng, and a little bit about myself. I've been studying optimization and algorithm design almost the whole my life, and I really find it really enjoyable to apply everything I learned in order to optimize the Dasher assignment problem in DoorDash. That's exactly this problem that Alice just introduces. Today, I'm going to share a slightly different topic on the experimentation process within the assignment team. We also have a blog post with the same title. Feel free to check it out if you are interested. So, within the next slide, please. As Alice has mentioned, experimentation is really the key to our assignment product iteration, also the algorithm development. Every product change and also algorithm change, we rigorously went through the experiment pipeline. That's how we increased the experiments 4 years ago before I joined, from a single digit to the currently 100 experiments per month. That's big for a 20-each team, a team of 20 each members. Today, I'm going to share some practices that help us scale up our experiments. As you can see in these slides, there are really 4 important pillars that help support our experimentation framework. The first one is the culture. Second one is the process. Third one is the statistical methods. And then the last one is the platform and the tooling. Now let's talk about the culture that we build. In DoorDash, we really operate with the fail fast and then learn fast culture. And within assignment team, we really try to integrate this culture into our experimentation process. We encourage everyone to fail fast, which means that you can occasionally break things. We really get the leadership support from people like Lohan to try different kinds of experimentation. And also within the team, we really take all kinds of preventive measures so that the risk is heavily mitigated. After we fail fast, we collect all kinds of data. Then the team always operate at the lowest level of details to study and maximize the learning from the experiment. Once you have a fail fast culture, then you can really generate a lot of experiment ideas. And then the team really needs to convert those experiment ideas through a process into the real experiment that's in the production system. We find that a key part of this process is to have a standardized experimentation metrics. The goal metrics and the guardrail metrics are really important because it's going to define our sweeping criteria. And based on these sweeping criteria, then people know what to expect. We also have some diagnosed metrics that help everyone analyze their experiment easier. The second part of the experiment process is our tool filter system that allows us to run as many experiments as possible and also get an accurate measurement of shipped experiment. Every experiment went through at least two weeks. The first week in the zone 1, where you share the experiment volume with many other experiments. And then the second week, we have some good candidate in a separate zone that can accurately measure its product, like its impact. The third part of the process is our experiment cadence. This cadence is at a weekly level, and it requires seamless collaboration between our product team, the experiment owner, engineering team, and also other cross-functional team members of assignment. After you have a defined process, the number of experiments really goes up, and then that's when the statistical methods comes in. We really need to make sure that all the experiments are analyzed scientifically to get accurate results. Note that the assignment problem tries to coordinate between deliveries, which means that there are networks between deliveries and you cannot randomize your experiment at the delivery level. That's why we run switchback experiment, which seeks to randomize a region and at a time window. Every region at a time window, it has it's either assigned a control algorithm or the treatment algorithm. Within the team, we have tried many efforts in order to optimize the switchback randomization units. That is, what's the time window size which we use, what's the window size, and the region size which we use. Another aspect that we spend a lot of time is the switchback experiment really has low experiment power. That's why you need to study various statistical methods to reduce the variance of your metrics. After several iterations, we converged to a method that leverages machine learning to construct a covariate into your experiment analysis. This covariate, we try to maximize its correlation with the goal metrics. As you may notice, we also have multiple experiments running simultaneously within the same region at the same time. That's why we need to have a methodology that in order to study the interactions between experiments and then make the decisions accordingly. Here, we want to give special thanks to Professor Sandy from Stanford University. He helped us develop all those methodologies. Once we have so many experiments, you cannot do everything manually. That's why automated experimentation platform and then tooling is important. Our tooling has two major parts. The first one is help with the experimentation setup. We have the team develop in-house infrastructure that's tailored to our switchback experiment. It's easy to set up to do just some JSON, and the team has a real-time format in order to monitoring and then debugging the experiment. This infrastructure is well integrated with our deployment process in order to avoid the errors and then mitigate the experiment risks. The second part is the experimentation analysis. We standardize all those metrics and also the experiment analysis script. The experiment platform team provide us with the analysis platform. The right picture is a snapshot of the experiment UI. And also within the team, we develop some experiment customized dashboard to summarize and also monitor each experiment. Yeah, and that's what I have discussed today. So we have developed a framework of experiment with the culture, process, methodology, and also platform to support our experimentation framework. Next, Aditya is going to talk about the efficient merchant logistics.
Thank you, Sifeng. 1000% increment in anything is an incredible feat. It also talks about how DoorDash is scaling up. Hi, today I'm going to present about efficient merchant logistics. I'm Aditya Dodda, an engineer on merchant efficiency team. Been at DoorDash for nearly a year, and prior to this, I've solved numerical optimization problems in multiple places. All right, next slide, please. All right, so our objective in the team is to make merchant operations efficient. Why do we care for this? We care for this because we want higher quality product for our consumers. We want faster deliveries for our dashers, and that allows for a better economic opportunity for them. And in turn, all of this allows for greater brand affinity and more sales for our merchants. And this way we keep the three parties in our marketplace happy. Next slide, please. Okay, so let's go with the basic understanding how we started off to achieve this objective. To understand that, let's look at the order flow. In simple terms, the consumer places an order, the merchant would receive it, prepare it, and then the dasher would deliver it to the consumer. But there are scenarios where a merchant may not be able to take the order. And this is where we started by dreaming big and starting small. We took our operations team, took a manual approach, and for some stores, and primarily during holidays, we would check if they could cater to the orders coming in. Okay, and there were some challenges with this. Next slide, please. Okay, so what were these challenges? Firstly, there were some preemptive actions that needed to be taken care of. So we had to proactively make sure that stores would be closed during holidays, and then if there were any other issues that were possible. Naturally, we couldn't track everything. So then for untracked issues, we had to troubleshoot when problems came in, which involved someone in operations to call a merchant, talk to them, or do more database queries and try to figure out the situation. And lastly, scaling up. For anyone who's worked on large scale systems, it is pretty clear that manual intervention can be disastrous for scaling up. And now that we are talking about millions of stores in DoorDash across multiple countries, that can get a lot more challenging. Next slide, please. Okay, so how do we keep the system same, but try to make it automated and help for smooth operations at scale, right? So this is when we started real-time merchant intelligence pipelines. And what these pipelines are doing is in real time, taking metrics from merchant and dashers, and then deciding whether the merchant can actually cater to more orders. Next slide, please. Okay, so here are some examples of our pipelines. Again, I want to emphasize that it's a few, there are more, and there are more complex ones, but these should give a gist of what we are working on. So for example, we have dasher wait time. This is the amount of time a dasher would wait at a merchant to pick up food. Then there's kitchen capacity. What this means is every merchant has some capacity they can handle during different times of the day and during different days. And there is this ideal sweet spot at which they can handle the influx of orders. And we want to keep the merchants operating at this stage because that would optimize for quality while giving them as much revenue as possible. There are other metrics that we track too, like order cancellations, point of sale outages, store closures, and merchant tablet activity for merchants who use tablets. Next slide, please. All right, so previous, yeah. So this some details on one of our pipeline. This is for dasher wait time in specific, but this should give you a gist of how many of our pipelines operate. So like I said before, we are looking at different metrics, and all these metrics go into some Kafka topic. And from there, we do an aggregation. Ezra? Okay. Yeah. So from the topics, we do an aggregation using our Flink pipelines. And in these Flink pipelines, we actually, for this example, look at median. Why do we look at median instead of average? Because we want to give the merchant a benefit of doubt in case they had one bad delivery, right? Once we have these aggregates and other metrics, we then use ML models and other heuristics to decide if the merchant can handle more orders. And we are doing all this in real time for millions of stores and millions of deliveries a day. All right, next slide, please. So keeping in line with our core value of 1% better every day, to conclude, we have been able to increase deliveries by millions, improve delivery times, which has led to increasing dasher revenues. And of course, since more deliveries means more orders, a higher revenue for the merchant. Thank you.
Awesome. Thank you so much, Aditya, and to all the presenters. Those are really cool presentations and all kinds of really interesting work that's fed into them. Quick reminder to the folks that are attending that you can also ask questions and look for updates in the chat. So I believe, panelists have been answering questions as we've gone along. If you do have questions, feel free to post there. And there are also links to some of the cool blog posts that these folks have written if you want more details, you want to review any of the content that they have discussed. With that, I think we can actually jump into the panel section of this discussion. So we have some other folks from the team who are here today who are excited to answer some questions. So I'll kind of moderate the panel and we can maybe start with introductions actually. So we can go through the panelists and have each one of them introduce themselves just briefly before we get into some of the questions. Saba, would you like to start?
Sure. Hi, my name is Saba. I've been at DoorDash for 5.5 years. I'm currently an engineer in the logistics department, where I focus on helping us improve the reliability of our systems.
Awesome. Thank you, Saba. And then next up, Zainab, would you like to go?
Yeah, for sure. Hi, so my name is Zainab and I'm a machine learning data scientist on the supply demand team. I've been here for almost a year and it's been pretty interesting. On supply demand, we specifically work on market balancing. So essentially ensuring that customers get their orders in a reasonable amount of time and Dashers are satisfied. So it's been a pretty great year.
Perfect. Thank you, Zainab. And then Kosha, would you like to go next?
Yeah, thank you, Rohan. Hi, everybody. I'm Kosha from the logistics teams. I'm also a software engineer. On that, I work with Saba on this team. We basically focus on building out the core fulfillment features and maintaining the reliability. For example, we do Dasher location tracking and delivery assignment tracking as well. Thank you.
Perfect. No, thank you. And then last but not least, Mark.
Hey, I'm Mark. I'm an engineer on the driver growth team. So how do we get new drivers signed up and on the road as quickly and efficiently as possible? I've been at DoorDash for about 5 years now and loving every minute of it.
Glad to hear. Awesome. Well, thank you all for the intros. I'd love to just dive into the first question. And it's a bit of a broad one, but I'd love to hear from a couple of folks, what is the biggest challenge on the horizon for the logistics team, in your opinion? Maybe Zainab, would you like to speak to that?
Yeah, for sure. So because I'm a data scientist, I can sort of like add my perspective here. I joined like a year ago and I feel like the scale of the problems that we solve here, sort of changed drastically during COVID. And it became kind of impractical to rely on ops intervention so heavily. And ops is basically operations and, like they play a really, really big role in a lot of things, a lot of decisions here at DoorDash. So in 2021, we essentially like worked on some foundation projects to automate away a lot of this stuff. Case in point, some of the work that Stas presented just now. And I feel like the next thing that we need to worry about is reliability and maintenance of all of these new living systems. And I feel like, we're doing a pretty decent job, but I feel like it needs to be even better. And reliability and maintenance can look, very different on the data science side. Just a simple example of that is forecasting. We have highly performant models, which we train on regular cadence. And yet we run into forecast degradations all the time. So it's basically like about answering whether this degradation is just a temporary blip that will self-correct or if it's something that needs to be attended to, more seriously. So things like that. I feel like this kind of like automating away the part which like even like maintenance and like making sure that everything's working perfectly, I feel like is something of a challenge and it's something that we need to continue working on.
Yeah, absolutely. A challenge that gets more and more acute the larger we get, I'm sure, right? Just there's so many things that can go wrong. Scale is another factor. Saba, I'm actually curious to hear from you too. I know you're a man who thinks a lot about scale here at DoorDash. What are your thoughts in terms of some of the biggest things that are on the horizon in terms of challenges for logistics?
Yeah, actually quite similar answer. But the biggest challenge in my opinion for logistics is also probably applicable to most other teams at DoorDash. But it's basically moving faster while simultaneously improving reliability. Doing that and there and not or is the unique challenge. Teams are growing, services are increasing and getting more complex. Call volume is increasing. We built all this infrastructure to enable local economies and make deliveries happen in the physical world, and we need to continue to scale it and improve it while also making sure customers have the best experience possible and maybe even improving it as much as we can as well. For logistics specifically, this means continuing to improve our efficiency, continuing to provide Dashers with more opportunities to earn income, and doing all this while enabling entirely new business models and verticals.
Yeah, no, absolutely. On this topic of scale and reliability, even as we kind of build a better product, Kosha, I'd love to hear from you. I know you work on the logistics platform team. Logistics, of course, is at the forefront of a lot of the scale and reliability challenges, given the criticality of these services. So yeah, would love to hear from you sort of one of the biggest, particular scaling challenges that you feel you faced recently.
Yeah, that's a good question. So one of the biggest challenges that we faced was also a recent one, where so one of our biggest databases, which is the delivery database, as you know, is at risk of not being able to scale any further. So because it's kind of reaching a lot of our RDS like database limits on that the AWS Aurora provides. So for example, we are on the largest instance that the AWS provides. We also are spiking our active sessions many times beyond our comfort level. And then basically various search thresholds. And so now we are at point that we also want to support like multi-region and also support many more connections to the database. And so we are involved in a huge work stream where we are trying to migrate the delivery database outside into a distributed SQL database.
Yeah, no, that's a big undertaking to say the least, and a lot of things that can go wrong. And I know the team has spent a lot of time and attention to make sure that we've done that as smoothly as possible while still moving as quickly as possible to meet the growing demand. That's definitely on the technology side and the reliability side of the scale. I'd actually also love to hear from Mark. You know, as a member of the Dasher growth team, you know, onboarding Dashers can be very different from country to country. DoorDash, of course, having launched in a variety of countries over this past year and even in the years before that. I'd love to hear from you how international expansion has affected our systems and approach to building products.
Yeah, I think it really just enhanced the criticality of something that we already knew we wanted to work on. The interesting thing about Dasher onboarding is in the core, simplest essence of it, it's not that crazy complicated. We're basically taking an employment application and creating some information in our database for you. The complexity comes from the fact that it is very multifaceted and multi-segmented depending on what kind of experience you have. If you sign up in Australia, it's different due to local legalities than it would be in the United States. If you sign up and you want to be a bike dasher, then there's no reason for us to run any checks on driving record, anything like that. So the biggest challenge of scale for us has been figuring out how do we scale our code in a way that the engineers can maintain it, keep things super modular, and make it so that we can continue to build on top of it in an efficient way. So we actually just finished doing a very large re-architecture in Q3 in preparation for some new country launches, where we basically just took a step back and said, how do we scale this thing out better? What are the paradigms that we need to shift towards? And what is the code that we need to rewrite? And we took a large team tackling that in the last quarter.
Yeah, no, and absolutely. I know building for one country is hard enough. Building for so many countries and thinking about the generalizable components versus what needs to be specific just becomes that much more complex. So no, thank you for speaking to that, Mark. And actually, while I have you, I'd also love to hear your perspective, shifting gears a little bit from scale and growth and these types of things to the culture side. I'd love to hear what you think is sort of the best part of your team's working culture.
Yeah, I'm going to give you two things. I think one is that you've heard a couple of people say like one team, one fight is one of our company values. Everyone is always willing to help out, even if it means putting their thing on the back burner for a few minutes. And I think that's incredibly helpful, both in terms of making sure we're getting the right things done and able to cross prioritize if needed. And it's also nice just to know that like your teammates have your back. I really love that. And secondarily, I'd say that DoorDash is definitely some place where I feel very poised to grow because of my teammates. I think everyone is very humble and hungry to learn. And I think that makes work not just, hey, how do I solve this challenge? It's how do I and how does everyone around me get better at what we do? Along with our systems. And I find that incredibly powerful.
Yeah, no, that's really great. And I do think that how we work together is really, really important in terms of the types of things we can actually achieve. In a similar vein, Saba, I'd love to hear from you again, maybe the most rewarding part of what you do at DoorDash and why.
Yeah, it's actually also very similar to what Mark said. For me, it does boil down to the people. The value of we are one team, which we often summarize as one team, one fight, is actually one of the most rewarding parts for me. Over the last 5.5 years that I've worked here, there have been so many different interesting and complex challenges that we've overcome. And not all of them are technical, but what's common here is that, in the aftermath of these challenges, you look back and you see this massive collaborative team effort. And knowing that none of this is possible without everyone working together, from employees to dashers, merchants, and consumers, makes all of this for me uniquely rewarding.
Totally. And Zainab, from the data science perspective, I know slightly different reporting structure, still embedded, working very closely with these teams. Would love to hear your perspective and take as well.
Yeah, so I feel like the most rewarding part of what I have like been basically working on, it's just basically like seeing the impact of everything that I work on, especially in logistics. I feel like it's something that you see in real time. It's the results of whatever decisions you make are apparent like really, really fast. And I sort of like love being able to see anything showing results in a really short amount of time. You know, we have like a lot of experimentation over here, and anything that we work on, you know, we run experiments for. And I feel like just seeing, you know, Dasher satisfaction grow, Dasher retention grow, Dashers feeling better is just exceptionally rewarding.
Fantastic. No, thank you. I did want to actually also cover some of the questions from the audience too. I see them piling in. So one question maybe for some combination of Kosha and Saba from the audience was, what might be some challenges and accomplishments involved with making logistics technology multi-region friendly? So perhaps talking about our multi-region strategy. I don't know if either of you wants to speak to that.
Sure. Saba, do you want to take this or you want me to?
You can start and then I can add thoughts.
Yeah, so from what I have seen so far, the biggest challenge is also to understand when a request comes in, how do you categorize that into like which region the request has to go on? And so this has to trickle down from the client to the deep level of the backend systems that we have. And, you know, dividing all the requests into these different regions is one of the great challenges that I've seen in this work stream.
Yep, I totally agree with that. Yeah, making the data effectively available multi-region is definitely a challenge. And when you have multiple regions, it makes reliability more difficult too. Like if you want to be able to fail over to different regions and whatnot, that adds more complexity to the system. And also maybe quickly to answer a question you didn't ask, what also makes it a little bit easier for us as a logistics team is that logistics is at least currently predominantly very localized as well. So that helps to some degree as well.
Yeah, totally. No, thank you both. Appreciate it. And then one more question. I think we're just about out of time. What are some of the interesting cross-functional challenges the logistics team encounters in working with other departments? So, you know, with data science, operational efficiency, merchant, consumer, these other organizations. Does anyone have perspectives on that and on how those collaborations can occur and some of the challenges that you all face? Maybe Zainab, would you like to speak again from the data science perspective?
Yeah, so I feel like cross-functionally we interact like quite often. I mean, within data science, obviously we have like different product verticals within logistics as well. So we have pay and like assignments. Alex already sort of spoke to it. Stas is with me on supply and demand balancing, but also we interact like with the engineering side as well as with the ops. And I feel like it can be kind of tricky. So it's like it's part of like sort of balancing, you know, all of the questions from ops as well as finance. We basically work with like a lot of teams, and every team has like a different perspective of how things should be. So specifically, I feel like as a data scientist, it's really, really important part of my job to make sure that I research things well enough, or like I prepare well enough for all of the questions that they might ask. But I feel like we work together pretty well so far, at least. I've only really been here for a year, so.
Yeah, no, totally. It kind of echoes what Mark was saying earlier, I believe, as well, about that one team, one fight mentality and how kind of folks come together and pursue that common goal as if they're just the same team, as it were. Awesome. Okay, I think that pretty much is all the time that we have. Since it's 1:01 p.m., I don't want to keep folks too far over. But thank you again so much for everyone who was able to attend. Thank you for the thoughtful questions. We'll try to get through as much of this Q&A as possible, but really do appreciate everyone from the presenters to the attendees for taking the time to attend this discussion. Cool. All right. Thank you again. Appreciate it.